Please remember that the process of modulation that we carry out on the transmitter side, which is the process of translating low frequency range to high frequency range, on the receiver side, to extract my original information signal back, we will have to send the signal through an opposite process. So on the receiver side, what takes place is called demodulation. For the process of demodulation, please remember that we require carrier signal. The carrier signal that was required in the process of modulation is also required in the process of demodulation. Now the question is, from where carrier will come on the receiver side. When you transmit double sideband full carrier, you are transmitting carrier also as a part of the signal, and hence the receiver can extract the carrier out of DSB-FC signal and use it in the process of demodulation. The problem occurs when the signal that you have transmitted is DSB-SC or SSB-SC. That means we have not transmitted carrier at all. Then the question is how the carrier will be generated on the receiver side. So in case of DSB-SC or SSB-SC signals, the carrier must be generated locally. Locally means on the receiver side, there will be a local oscillator which will generate the carrier signal at the same frequency and phase which the original carrier on the transmitter side had. And that carrier will be used in the process of demodulation. Now it is very obvious that if the carrier which is used on the transmitter side and if the carrier which is used on the receiver side are not exactly same, then the demodulation process will not be exact reverse of the modulation process, and hence there will be distortion in the demodulated signal. To avoid this distortion, the carrier used on the receiver side has to be exactly same as the carrier which is used on the transmitter side. The only way in which this can be achieved is by transmitting carrier along with the signal. That means transmitting the full carrier version, for example. In such a case, the carrier will be extracted from the received signal, and hence it will be exactly the same carrier that was used on the transmitter side. Now this does not make any sense, because at one point we are saying that carrier should not be transmitted because it occupies a lot of power, and now we are saying that carrier is required so that the distortion in the demodulated signal will be less. Now what is the solution to this? The solution is that we do transmit carrier with the two or sidebands or the single sideband, but we do not transmit the entire full carrier. What we do is we transmit a very small part of the carrier. This full carrier, if it has the amplitude of Vc, only then it occupies a lot of power. What if I attach a carrier to single sideband which is of very weak amplitude? In that case, the power occupied by the carrier will be very small, and hence efficiency will still be very large. And this is what we call the fourth type. Here we transmit one sideband, which can be either of upper sideband or lower sideband, and RC stands for reduced carrier. So in this case, we call it SSB-RC, single sideband reduced carrier. So what is reduced carrier? It is a small weak amplitude carrier signal which will not occupy a lot of power, but it will help receiver to extract the carrier from it and use that carrier in the demodulation process. This will avoid the distortion which otherwise takes place. Now, like we have SSB-RC, we can also have DSB-RC, double sideband reduced carrier, but what is more preferred is SSB-RC signal. So SSB-RC signal can be called the best type of AM because its efficiency is still very high. It requires bandwidth of only FM because we are transmitting only single sideband, and because it also has a small carrier on the receiver side, the receiver can extract this carrier and use it in the process of demodulation, which also keeps the distortion to its minimum. So these are the various types of AM signal.